Hello and welcome to this Python tutorial. So in the previous section we introduced our business problem and today we are going to solve it using k-means in Python. So here we are in Python. First thing that we have to do is set our working directory. So we click on this folder here, then we go to our machine learning folder, then part 3 clustering, and eventually we open our k-means clustering section folder and we click on choose. Perfect, that found our folder that contains the dataset. And let's not forget to click here to set our folder as working directory. And now let's implement our k-means algorithm step by step. So first step as usual is to import the libraries. So we write the comment importing the libraries. And just below we import the three essential libraries: NumPy to use mathematics, Matplotlib to plot nice charts, and pandas to import and manage datasets more easily. We select our three imports and we press Command and Control plus Enter to execute them. Perfect. Now let's move on to the second step, which is to import the mol dataset with pandas. Okay, so here I'm going to write this comment to introduce this new step, importing the mol dataset with pandas. And to import this dataset, we simply write dataset equals pd.read_csv, and in parentheses we put the name of our dataset in quotes, mol.csv. Make sure that this dataset is in your working directory folder, and if that's the case, let's select this line of code and execute. Great, now let's go to Variable Explorer to see what our dataset looks like. Here it is. Let's double click on it, and that opens the mol dataset. Okay, so let's re-explain what this mol dataset is about and what our mission is. There is a big mall in a specific city that contains informations of its clients, the clients that subscribe to the membership card. When the clients subscribe to the card, they provided their information like their gender, their age, and their annual income. And because they have this card, they use it to buy all sorts of things in the mall, and therefore the mall has the purchase history of each of its client member, and that's how they obtain the last column here, which is the spending score. So as a reminder, the spending score is a score that the mall computed for each of their clients based on several criteria, including, for example, their income, the number of times per week they show up in the mall, and of course the amount of dollars they spent in a year. And based on all this, they computed this metric that takes values between 1 and 100, so that the closer the spending score is to 1 and the less the client spends, and the closer the spending score is to 100, the more the client spends. And eventually, after collecting this dataset, the mall company hired you as a machine learning scientist to segment their clients into different groups based on these two metrics, the annual income and the spending score. And since the mall has no idea of what these client segments might be, or even has no idea about how many segments there would be, this is typically a clustering problem because we don't know the answers. So now let's start our mission and use the k-means algorithm to find out what those clusters of clients might be. So here we just imported the dataset. This dataset has been imported by Panda as a data frame, and now we are going to build an array containing the two columns we are interested in, the annual income and the spending score. And to do that, we simply write x, which is the name we give to our array, equals dataset.iloc, and in square brackets, a colon to specify that we want all the lines, comma, and now again in square brackets, we're going to put the two indexes of our columns. So let's see, let's open again the dataset. Indexes in Python start at 0, so we count 0, 1, 2, and so annual income has index 3, and spending score has index 4. Okay, let's close that and let's get back to our code. We put here the two indexes 3 and 4 of our columns of interest, and eventually we end this line of code by .values. Okay, let's select this line of code and execute it. Perfect. It created the array X of our two columns, which we can visualize here by double-clicking on X. So now we are done with importing our data, and we are ready to move on to the next step. And that's when things start to get interesting, because right now we are going to start using k-means specifically. Okay, so since we have no idea what to look for, we actually don't know the number of clusters of clients to look for. And remember when we got our k-means intuition in the previous section, we saw that when we use k-means, we have to choose this number of clusters. And that's exactly what we are going to do right now. We are going to find out the optimal number of clusters for our problem. And to do this, of course, we're going to use the elbow method. So let's introduce this new step with the following comment, using the elbow method to find the optimal number of clusters. First, we import the k-means class from scikit-learn. So we write from sklearn.cluster import k-means. And now let's plot the elbow method graph. So to plot this graph, we are going to compute the within cluster sum of squares for 10 different numbers of clusters. So since we're going to have 10 iterations, we are going to write a for loop to create a list of the 10 different within cluster sum of squares for the 10 numbers of clusters. So we start by initializing this list that we call WCSS. WCSS equals empty square brackets. And then we start our loop. For I in range 1 to 11. So we choose 11 instead of 10 because the 11 bound is excluded and we want the 10 WCSS. However, the first bound 1 is included. So here I is going to take the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now in each iteration of this loop, we are going to do two things. First, we will fit the k-means algorithm to our data x, and second, we will compute the within cluster sum of squares and append it to our WCSS list. Okay, so let's first fit k-means to our data x. We are going to create an object of the k-means class and call it k-means. So we write k-means, that's the object, equals k-means with capital K and M, that's the class, and within this class we're going to input several parameters. The first parameter is n clusters, the number of clusters. And because we are testing several number of clusters to build our elbow method graph, the number of clusters and clusters here is going to be our variable I that is going to take the values from 1 to 10. Next parameter is init, the random initialization method. You can choose random if you want a complete random choice of your initial centroids, but we don't want to fall into the random initialization trap. So we're going to choose this very powerful method that we saw in the k-means intuition sections, which is of course the k-means plus plus initialization method. And therefore here we write init equals k-means plus plus between quotes. Then the next parameter is max iter. This is the maximum number of iterations there can be to find the final clusters when the k-means algorithm is running. The default value for this parameter is 300, and that's the value we are going to choose. Then the next parameter is ninit, which is the number of times the k-means algorithm will be run with different initial centroids. The default value for this parameter is 10, and we will leave it to 10. Then there are other parameters that we can add, like the tolerance for convergence, but we won't go into the details of them because we're going to leave them to their default values. Indeed, by not adding them into these parentheses, they keep their default values. However, let's add here the random state parameter, which fixes all the random factors of the k-means process, so that when we set it together to the seed 0, we will all get the same results. But you're welcome to try another seed or even remove this random state parameter to see what happens. Okay, so now we prepared the k-means algorithm, but we still need to fit it to our data x. And to do this, it's very simple. We just write k-means, which is the object that we just created, dot, then fit, and in parentheses, x. So fit is a method of the class k-means that of course fits the k-means algorithm to your data. And now let's do the second thing, which is to compute the within cluster sum of squares and append it to our list WCSS. There is actually another name for within cluster sum of squares, and that's called inertia. And thanks to the awesome scikit-learn libraries, there is actually an inertia attribute that computes the within cluster sum of squares. So to compute the within cluster sum of squares, we write the code k-means.inertia with an underscore. And to append it to our WCSS list, we write the code WCSS.append and in parentheses we put the inertia computation k-means.inertia. Okay, so we are done with our loop, and now we are going to plot the elbow method graph. So we write plt.plot, and then in parentheses, first we input the x-axis values, which are range 1 to 11 because we wanted 10 numbers of clusters, then comma, and then we put the values of our y-axis, which are of course WCSS. Then let's add a title to our chart by typing plt.title, and in parentheses we input the title, the elbow method. Then let's add a name to our x-axis by typing plt.xlabel and in parentheses number of clusters. And same, let's add a name to our y-label by typing plt.ylabel WCSS. And last but not least, to display the chart, we type plt.show parentheses. Alright, now I'm very excited to select this code section here and execute it to find out if there is an optimal number of clusters. So let's do that. Let's select our code here, Command or Control plus Enter to execute. And wonderful, we obtain a beautiful elbow method chart with a very obvious optimal number of clusters, which turns out to be 5 clusters. Indeed, we can see that the elbow is here, and when we project this point on the x-axis, we obtain x equals 5. Perfect. So now that we have the right number of clusters, we are ready to move on to the next step. And the next step is to apply the k-means algorithm on our data x, but this time with the right number of clusters. So let's introduce a new code section with the comment applying k-means to the mul dataset, and let's immediately fit the k-means algorithm to our data x with the right number of clusters, 5 clusters. So we already know how to do that since this is exactly what we did in the loop, and accordingly we write k-means, the object, equals k-means, the class, and in parentheses we input number of clusters and clusters equals 5. Then for the random initialization method we put init equals k-means plus plus, and then maximum of iterations 300, and init equals 10, and random state equals 0. So that's how we prepare k-means, and now we have to fit it to the data x. Only this time we're not going to use the fit method, but we are going to use the fit predict method that returns for each observation which cluster it belongs to. So that means that for every single client of our dataset, the fit predict method is going to tell us the cluster to which the client belongs. And it will return these cluster numbers into a single vector that we're going to call yk-means. And therefore here we write yk-means equals k-means.fitPredictX. Okay, perfect. Now let's select this code section and press Command or Control Enter to execute. Done. And now if we go to Variable Explorer, we can see that we have our new vector of cluster numbers yk-means right here. So let's double click on it to open it, and let's also open the dataset. And now we can see that customer number 1 belongs to cluster number 4, customer number 2 belongs to cluster number 3, customer number 3 belongs to cluster number 4, and so on. Okay, so let's close that and move on to the next step. This next step is actually the final step, and this is where we get all the fun. Because we've done our job, fitting the k-means algorithm to our dataset, and now we look forward to seeing the results. And we are going to make sure to plot a beautiful chart with our 5 clusters well represented. Okay, so let's introduce this new step with the comment visualizing the clusters, and let's begin to plot the results. So basically we're going to make a scatter plot of all our observations, on which we're going to add the centroids and of course the clusters that we will make sure to highlight properly. So we write plt.scatter, and let's start by plotting all the observations belonging to cluster 1. Before we move on, let's just notice that in this yk-means vector, the cluster numbers are not from 1 to 5, but from 0 to 4. So that means that our first cluster, cluster 1, corresponds to yk-means equals 0. So in plt.scatter, we first take our dataset x, then in square brackets, we specify that we want the observation that belongs to cluster 1 by writing yk-means equals 0, and then comma, and then we specify that we want the first column of our data x, So we type 0 because indexes in Python start at 0. And by doing that, we gave the x-coordinate of all the observation points that belong to cluster 1. And now we have to do the same for the y-coordinate. So here we type comma, and then x, and in square brackets, yk means equal 0, and then 1 that corresponds to the second column of our data x, that is the y-coordinate. Good, and then we choose a size for our data points. Since we don't have too many observations, a good choice of size here is 100. Then we pick a color for our cluster. Let's pick red. And then we give a label to our cluster that we are going to call cluster 1 for now. And now let's copy paste this line of code 4 times to do the same for the other clusters. So here we put 1 for the second cluster, then 2 for the third cluster, then 3 for the fourth cluster, and finally 4 for the fifth cluster. Okay, and let's of course change the colors. Let's choose blue for the second cluster, green for the third cluster, cyan for the fourth cluster, and magenta for the fifth cluster. And of course, eventually we change the cluster labels: cluster 2, cluster 3, cluster 4, and cluster 5. Okay, and now let's plot the centroids. So it's the same as for the observation points, only this time we're going to use the cluster centers attribute that returns here the coordinates of the centroids. And to highlight them well, we're going to choose a bigger size, s equals 300, and the star color yellow. And of course, we change the label to centroids. Then we add a title to our plot by typing plt.title clusters of clients. Then let's specify the name of the x-axis by typing plt.xlabel annual income $k, and the name of the y-axis by typing plt.ylabel spending score 100. Then since we specified all the different labels, we want to add a legend, so we type plt.legend. And last but not least, we want to display the chart, so we type plt.show. And now, moment of truth. Let's find out what our 5 clusters look like. We select this code section here, and let's press Command or Control plus Enter to execute. Voila, our 5 final clusters. So let's look at them one by one. Cluster 1. Clients in Cluster 1 have high income and low spending score. So in this cluster, clients earn a high income but don't spend much money. So we could call this cluster of clients Careful, for careful clients. Cluster 2. Clients in Cluster 2 have average income and average spending score. So let's call this cluster of clients Standard. Cluster 3. High income and high spending score. So that is the cluster of clients that would be the main potential target of the mall marketing campaigns, and so it would be very insightful for the mall to understand what kind of products are bought by the clients in this cluster. So eventually we can give to this cluster the following name: Target. Cluster 4. Low income but high spending score. So clients in this cluster earn a low income but don't care and spend much. So let's call this cluster of clients Careless. And eventually cluster 5, low income and low spending score. So as opposed to the careless clients who have low income and spend much, we are going to call them the sensible clients. So now let's reselect and execute this code section with the correct cluster labels, and we get our final chart of the clusters of clients. Alright, we are done with the k-means algorithm in Python. Look at our code, it's structured, simple, and it does the job perfectly well. And you can use this code anytime you want for your work. You just have to replace the name of the dataset, change the indexes of the columns of interest, and then you just have to execute this code to find some answers of your business problem. And if you are doing clustering in more than 2 dimensions, then don't execute the last code section to visualize the clusters, because it's only for 2-dimensional clustering. However, later in this course, we will learn a technique that allows us to reduce the dimensions of our dataset. So if you reduce your dataset to 2 dimensions, then you can use this last code section to plot the clusters. And now to finish this tutorial, let's clear everything and reset by executing this line of code here without the comment. Let's also go here and press Ctrl L to clear the console. We select the whole code, execute it, and we make sure everything works fine. Thank you for watching this video, and I look